So today is May 14th, and we're going to be talking about parametric functions, day 2. This is where a lot of the calculus is going to come in, okay? All right, so let's just jump in. It's going to be very similar to calculus we've already done, okay? So here's example 1. Find the lowest and the leftmost point on the graph of x equals 2 sine t and y equals t squared minus 4t on the interval 0 less than or equal to t less than or equal to 2 pi. Okay, so I produced a graph for you on this. Okay, and I should tell you, because you can't tell it from the graph, but this right here is our initial point. Okay, so that's our IP. Okay, and then the particle would move on this plane. It would start right here and it would move down and it would move down, and then it would wrap around here and then come back up. Okay, and it would end up right here, and right there, that's the terminal point. Okay, that's the final point at 2 pi where it would be located. Okay, all right, so looking at this, we can kind of eyeball it, right? But now calculus will get us precise, but we can eyeball it. Okay, what's the lowest point? Well, it's going to happen right about here. It's going to happen right about like 1.7, well, more than 1.7, probably like 1.8, 1.9, right? It's just to the left of 2, right? It's right there. Okay, so, and it looks like it's going to be, it looks like it might be -4, right? It looks like it might be touching that, but we don't know for sure. We're just kind of eyeballing it right now. Okay, so that'd be the lowest point. How about the leftmost point? Okay, so the leftmost point would be the one furthest to the left, and that's looking like it might be right about, probably right about here, -2 and 3. Okay, looks like it might be. Okay, we're going to find out for sure if it is. Okay, but that's kind of the like, how do we figure this out now using calculus? Okay, so we kind of looked at the graph and go, okay, I know what this means. Now how do we use calculus to show the exact value? Okay, and the way to do that is with derivatives. Okay, so we know it's going to be furthest to the left. Okay, well, actually, let's just find the derivatives of these. Okay, so dx over dt. Okay, so dx over dt, so x is 2 sine t, so dx over dt would be 2 cosine t. Okay, and then y is t squared minus 4t, so dy over dt, okay, would be 2t minus 4. Okay, so let's do this first. Okay, how do we find the lowest point? Okay, so the lowest point is going to happen when your y coordinate is at a minimum, right? That would be it, right? So this is the y value, right? The y coordinate right here, dy, right? Well, y is the y coordinate, okay? dy dt is the rate at which the y is changing, okay? So we would have to have that equal to 0, right? We'd have to have the derivative equal to 0. And this is really the closed interval test, because we have a closed interval, 0 to 2 pi, right? Okay. So to find the lowest point, we're going to set dy. Let me just write lowest point. Okay. What we're going to do is we're going to set dy over dt equal to 0. And solve it, okay? So that would happen when 2t minus 4 is equal to 0, right? And that would happen, that'd be 2t is equal to 4, and that would be t is equal to 2. Okay, now t is equal to 2, right? This is x and y over in the graph, okay? All right, so this is the closed candidate test. This is a relative, this is a critical number right here, right? Okay, this is never going to be undefined, but it could be 0, right? So we got to check the end points, okay, at t equals 0 and t equals 2 pi. And we're just going to, and t equals 2, which is a critical value. And then what's going to happen is we're going to look and see which one's the smallest, okay? So we're going to have t, and we're going to have y of t values. Okay, so we're going to do t is equal to 0, t is equal to 2, and t is equal to 2 pi. And we're going to put that into the y function, okay? So if we put 0 in here, we'd have 0 squared minus 4 times 0. That would just be 0, right? Okay. And then at 2, we would have 2 squared, which is 4, minus 4 times 2, which is 8, and then 4 minus 8 would be negative 4. Okay? And then at 2 pi squared, okay, would be 4 pi squared, and I'm going to write that 4 pi squared, minus, and then 4 times 2 pi, and that would be 8 pi. Okay, now let's talk about this. Pi is about 3, right? So 3 squared is 9, and 4 times 9 is 36, right? Okay, and if this is close to being 36, this one would have to be close to being 24, right? Because 8 times 3 is 24. So 36 minus 20, this one's bigger than this one. This is going to come out to be a positive value, right? So this one is, I'm sorry, this one right here is the minimum, right? Okay. Now, what is the x coordinate for this, right? Okay. So it's when x is, or the t is 2, right? So to find the x coordinate, what I'd have to do is put 2 in. So x is equal to 2 sine of 2. We could put that in our calculator, and that comes out to be about 1.82. Okay, so this is the x coordinate, this is the y coordinate at t equals 2. So this is the lowest point right here. Okay, so the lowest point, okay, is this point, and it would be, the x coordinate would be 2 sine 2, comma, negative 4. Or you could write this, if you put that in a calculator, right? 1 point, you know what? I want to go 3 decimal places. I'm sorry, guys. This is, and I did only 2. Okay. Let me change this. 1.819. Okay. So this would be 1.819, comma, negative 4. And does that, okay, does that match up with what we were thinking? Yeah, it does. Like right about there, right? 1.8, we said, and negative 4. Yeah, it's this point. That's this point right here. Okay. And yeah, that looks like the lowest point, right? So this kind of makes sense, right? Should, okay? It should, I'm using the graph to help us like understand it, okay? Because you can get lost in all this math, okay? All right, so the next thing is, okay, we want to know the leftmost, okay? So we would need to find where x is a minimum, right? Okay, so how do we find where x is a minimum? Well, we got to use the derivative, right? So we're going to set 2 cosine t equal to 0, right? And we're going to find the critical numbers for the dx over dt, okay? And then we're going to check t equals 0, t equals 2 pi, and whatever we get for where dx over dt is equal to 0, okay? So I'm going to slide this up a little bit, okay? So give us some room, okay? So then we're going to look at dx over dt, and we're going to set that equal to 0, right? Okay, and this is the leftmost. I should say that, leftmost. Okay, which means a minimum, right? Okay, so a minimum for the x coordinate, okay? So dx over dt is equal to 0, so that would be 2 cosine of t is equal to 0, which means cosine of t is equal to 0, okay? And then, okay, so what is it, where would cosine, what angle for t would give you cosine ratio that is 0? And we have to look between 0 and 2 pi, right? And this would be t is equal to pi over 2 and 3 pi over 2. Okay, so there's 2 of them that we're going to have to check, right? Okay, so that means for the leftmost point, okay, we're going to have to make a table, and we're going to have a t, just like we did before. And we're going to have our x of t, and we're just going to look for where x of t is the smallest, okay? All right, so we got to look at 0. We got to put 0 in, okay? And that'd be 2 times cosine of 0, and cosine of 0 would be 1, okay? So this would be 2, okay? And then we got to use pi over 2. And cosine of pi over 2 is 0, and 2 times 0 would be 0. And then 3 pi over 2. And when t is 3 pi over 2, okay, that would be 2 times cosine of 3 pi over 2. Well, it would be 0 again, right? Okay, and then finally, all right, we have to do 2 pi. You guys, I was putting this into the derivative. I just caught it. Okay, whoops, 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 whoops. I was putting these into dx dt. Okay, back up. Let's redo this, okay? Okay, so don't get me wrong. Everything's right. I was just using the table and I was using 2 cosine t, right? Let's make this correction. You probably said that 5 minutes ago. Mr. Mitchell, why are you doing that one? Okay, I do not know. Okay, so 2 sine of 0, right? That's the one we got to use. Let me slide it up. Okay, 2 sine of 0. We got to put into this one, not the derivative. My bad. Okay, so sine of 0 would be 0 times 2. So this is the one that's 0. Okay, I knew from my graph it wasn't making sense. So that's why I was like, you heard me pause and like, you heard the gears turning in my head, right? Okay, for the next one. Okay, so 2 times sine of pi over 2. Sine of pi over 2 would be 1, and 2 times 1. So this would be 2, okay? And then 3 pi over 2. Sine of 3 pi over 2 is negative 1 times 2 is negative 2. Okay, and then and that's starting to make sense, right? Okay, and then 2 times sine of 2 pi. Sine of 2 pi would be 0, so this would be 0 also. Okay, so right here, this would be the minimum, right? Okay, so now, okay, the leftmost point, and actually I need to figure out the x value there. Okay, so x, I'm sorry, we got to find the y coordinate. What is my problem right now? Okay, y is equal to, okay, and it's going to be at 3 pi over 2, so that'd be 3 pi over 2 squared minus 4 times 3 pi over 2. Okay, and that would be 9 pi squared over 4 minus, okay, and this would be 12 pi over 2, or 6 pi. Okay, and then we could put that into our calculator and we could get a decimal approximation just like we did for the 1.819. Okay, all right, because that's, you see right here is the leftmost point, right? And it's going to be, this number is going to come out to be close to 3, I think. Okay, I'm going to grab my calculator and we'll do this. Okay, so 9 pi squared over 4, and then minus 6 pi, and then 3.357, right? 3.357. And it's happening, and the x coordinate would be negative 2. Okay, so it is happening at negative 2, and it's 3.3. So it's really a little bit above this 3, right? It's right about here. Okay, let me use another color. So it's actually right about where I put that arrow. Okay, it looks like. So that's the leftmost point, and this is the lowest point, right? Okay, so the leftmost point is, okay, and the x coordinate is negative 2, and the y coordinate exactly is 9 pi squared over 4 minus 6 pi, or negative 2 comma 3.357. okay? And that's the leftmost. Okay, so the rightmost, okay, the rightmost would have been right here at t equals pi over 2, right? Okay, at 2, right? And that makes sense because it looks like it's right about there, right? It's a little bit to this lowest point, right? Just a little bit to the right of it, okay? And above it, okay? And so it'd be happening right here at x equals 2, and that would be the one furthest to the right, okay? Just to give you, I mean, because if I ask you lowest and leftmost, I could also ask you highest and rightmost, okay? All right. Okay, let's go to the next problem. There's a lot of space right here because there's some stuff I want to write, okay? So we know from yesterday that dy over dx, right? dy over dx is equivalent to dy over dt over dx over dt, right? Okay, and this next question is asking about this. Okay, find the points at which the tangent line to the curve is horizontal or vertical. Okay, so we know we have a horizontal tangent. Okay, when dy over dx, okay, dy over dx, right, is equal to 0. Okay. Now, what determines dy over dx is equal to 0 is when this numerator is equal to 0, okay? So we can find when you're going to have horizontal tangents when dy over dt is equal to 0, okay? So in parametric, it translates to this, dy over dt is equal to 0, okay? And that would be when we know we have a horizontal tangent, okay? How about a vertical tangent, okay? So vertical tangent, and that's going to happen when dy over dx is undefined. Well, what is it in parametric when dy over dx would be undefined? It would be when dx over dt is equal to 0. So the x isn't changing, right? So that means it'd be going straight up, right? If it was moving and dx over dt is 0, then it would have to be moving straight up because the x is not changing, okay? All right, so hopefully that makes sense, okay? Now, back to this, okay, we can tell from this graph, okay, this is you could write an equation for x and y for this, okay? All right, and right here, okay, we would have horizontal tangents, right? And my d right at that point, dy over dt is not changing anymore, okay? So it wouldn't be changing here, and it wouldn't be changing here, right? Okay, your y's would not be changing, okay? Now, where was it that your x's wouldn't be changing? And that would be a vertical tangent, right? And that's gonna happen right here and right here. And I'm gonna go through the work to show you that this really does happen, okay? All right. Okay, so here we go. Okay, so find the points at which the tangent line to the curve is horizontal or vertical. Okay, so let's do horizontal first, okay? Okay, so we need to set dy over dt. We got to figure that out first, right? And so dy over dt, well, derivative of 1 is just 0, right? And then plus 3 times derivative of sine t. Well, that'd be 3 cosine t, right? Okay. And you guys, I should have said this. This is between 0 and 2 pi. Okay. So we got to set dy over dt equal to 0. Okay. And that would be 0 is equal to 3 cosine of t. That would be cosine of t is equal to 0. And when is the cosine ratio going to wind up being 0? At what angles? Well, it's going to be t is equal to pi over 2 and 3 pi over 2. Okay, so those are the times in which this is going to happen, right? But what is the x and the y coordinates, right? So it should happen that we get negative 2, 4, and we should also get negative 2, 2. Okay, all right. So I'm going to make a little table. Okay, we'll do it right here. And let's do it down here. So I have t. Okay, and this is going to happen at pi over 2, and we're going to have x of t, and we're going to have y of t. Okay, so sine of pi over 2 would be 1, right? And so 3 times 1 is 3, with the negative 2 makes 1. So this would be 1. And then you guys just pause the recording because there's a typo here, and I was trying to figure it out, like, okay, what did I do wrong? Okay, I didn't do anything because this number wasn't making sense. Okay, so back to this. Okay, so like this is okay. So I feel stupid again, but this is a good learning experience. Like, you can catch things, right? Like, this didn't make sense. Like, how could the x be 1? That's not where you're gonna have a horizontal tangent, right? And that's because this trig function shouldn't be sine t. Okay, so I'm gonna cross it out. This should be cosine t. Everything else is right. It's just that should be cosine t. Okay, it's a typo that I didn't realize I hadn't fixed yet. Okay, so I need to change this. Okay, because now this is going to make sense. Okay, so when we put pi over 2 in here, right, what's cosine of pi over 2? That's 0. And 0 times this 3 would be 0. Okay, and then negative 2, right? So it's going to happen at negative 2. And that makes sense, right? X is negative, right? Okay. Okay, so then when t is pi over 2, x is negative 2, and the y would be, okay, so now for the y, what's sine of pi over 2? Sine of pi over 2 is 1, times 3 is 3, plus the 1 is 4. Okay, so that means there's a horizontal tangent right here at this point, negative 2, 4, okay? So where else is another one? Well, it's at 3 pi over 2. That's going to give us this one down here then, right? It should. It should. Okay, so 3 pi over 2, if we put in cosine of 3 pi over 2, okay, that would be 0 times this 3 is 0, okay? And then negative 2 plus that would be negative 2. Yeah, right? That the x coordinate right there is negative 2. Okay, how about this one? Okay, so sine of 3 pi over 2, well, that'd be negative 1. So that would make this negative 3. So it'd be 1 minus 3, which gives you negative 2. Okay, so now it's making sense, right? It's making sense. Okay. Sorry, guys. Okay, so find the points. Okay, so let's answer this question. Okay, find the points at which the tangent line to the curve is horizontal. Okay, so the tangent line to the curve is horizontal at negative 2, 4 and negative 2, 2. Okay, so we answered that question. Okay, so now how about the vertical one, right? So the vertical one would be where dx over dt is equal to 0, right? So vertical tangent. Okay, so the vertical tangent would be where dx over dt is equal to 0. So let's figure out dx over dt. Okay, so the derivative of negative 2 would be 0, and then plus, so 3, and the derivative of cosine of t would be negative sine t. So this is negative 3 sine of t. Okay, so we'd have to set this equal to 0. So 0 is equal to negative 3 sine of t. Okay, so that'd be 0 is equal to sine of t. And when is the sine ratio going to be 0? Well, it's going to be 0 at 0, right? And at pi and at 2 pi, right? Okay. All right, so now we got to figure these out, right? Okay, so then we're going to make a little table. I'm going to leave a little room because we're going to write our answer right here, okay? So let's make a table. And we have x of t, and we have y of t. Okay, when t equals 0, when t equals pi, and when t equals 2 pi, right? Okay, so what is the x when t is 0? When t is 0, okay, that'd be cosine of 0, that'd be 1, and then that'd be 3 times 1, which is 3, and then negative 2 plus 3 would be 1. Okay, and the y would be 1 plus 3 times sine of 0, right? And sine of 0 would be 0, so that makes this 0, so it'd be 1, right? 1, 1. And that's this point right here, right? Okay. Now, how about at pi? Okay, so negative 2 plus 3 times cosine of pi. Cosine of pi would be negative 1. And negative 1 times 3 is negative 3. Plus the negative 2 makes negative 5. And that should be making sense because that's this point right here, right? Okay, and we should get 1 out of this, right? So how about when we put pi in here? Well, what's 3 times sine of pi? Well, sine of pi is 0, right? 3 times 0 is 0. 1 plus 0, it's 1. Okay, now how about this 2 pi? Okay, so 2 pi. What happens is you're coming back and you're back on this point right here, okay? Because this is the first, this is the, right here, this is the initial point, but it's also the terminal point, okay? So it doesn't matter because when you put this in, right, cosine of 2 pi would be 1. 1 times 3 is 3. 3 and negative 2 makes 1, okay? 2 pi in this one, so sine of 2 pi would be 0 times 3 is 0 plus 1, right? 1, 1. We get the same point, right? Okay? So what does this mean? The tangent line, so let's write it right here, the tangent line to the curve is vertical at the point 1, 1 and the point negative 5, 1. Because this is the time at which that's the time at which the coordinates are at a point where the tangent is vertical, okay? All right, so that's example number 2, guys. Okay, let's go to some calculus. We're gonna do some different calculus now. We're gonna do parametric curve length, okay? So let's do that next. Okay, so for arc length in parametric form, if a smooth curve C is given by x equals f of t and y equals g of t, such that C does not intersect itself on the interval t, a is less than or equal to t, less than or equal to b, except possibly at the endpoints, okay, where you start and stop, like the initial point and terminal point, that's what they're talking about. Then the arc length of C over the interval is given by, and it's this right here, okay? All right, so when we did this with Cartesian regular functions, right? Y equals f of x, right? Okay, what happened is we took this, this became 1 plus dy over dx squared, right? So basically when you go into parametric form, okay, it's going to be dx over dt squared plus dy over dt squared, and we're going to integrate from a to b, okay? Now, looking at this right here, okay, if there's symmetry, sometimes we can take advantage of symmetry to help us figure out an easier way to do the integral, okay? So we could integrate from 0 to 2 pi and go all the way around, okay? All right, because that's what we could do, okay? Because there's no intersections, like they said. It's a nice smooth curve, okay? But when t is equal to 0, okay, let's figure out our initial point, okay? So at 0, okay? So cosine of 0 would be 1, right? And 4 times 1 is 4, right? So this is it right here, okay? Because sine of 0 would be 0. So this is the initial point, right? Right here. Okay, and as you go around, right, 2 pi would put you back, and so it's going to share, the initial point and the terminal point are going to be the same. Okay, So that means, okay, if you think about it, okay, this is kind of like the unit circle too. As you go around, as this thing's going around, you're picking up x coordinates and y coordinates based on trig functions, right? So you're going to be right here at pi over 2, okay? So right here, at this point right here, this one would be t is equal to 0. This point right here would be when t, and you could put your t's in and realize this too, okay? T is equal to pi over 2. Right here, this point right here is t is equal to pi. Okay, and then right here, this point right here would be t is equal to 3 pi over 2. And then we'd be back here on the terminal point, right? And that would be where t is equal to 2 pi, and we'd be back where we started, okay? Now, so to take advantage of the symmetry, this is a circle, okay? So if you look at this, okay, if we integrated from t equals 0 to t equals pi over 2 and multiply that arc length by 4, we would have the entire thing, right? Okay, now I just gave it away kind of, okay? This is a circle, right? It's a circle. What would this arc length be? Okay, arc length in terms of a whole circle would be the circumference of the circle, and that is 2 pi r, right? So 2 pi r. What is the radius here? Well, the radius is 4 because it's centered at 0, 0. Okay, so the radius is 4, so that would make this be 8 pi. This entire arc length is 8 pi. We did that without the calculus, right? So I'm saying that and pointing it out because what we should get out when we do the calculus is 8 pi. We already know what our answer is, okay? And I want to show you that this works because you're not always going to be able to do symmetry like we just did and go, oh, it's the circumference of a circle, right? You're not always going to be able to do that, okay? All right, so a few things we need to do is we need to calculate the derivatives because to find the arc length, we need to do derivatives, right? Okay, so dx over dt would be equal to, okay, so this would be 4 times the derivative cosine of t, and the derivative cosine of t would be negative sine of t, right? So this is going to come out to be negative 4 sine t. And then dy over dt is equal to, okay, so that'd be 4 times the derivative of sine t, right? So that'd be 4 cosine t. Okay, so here we go. Now, we're going to take the length, and that's equal to, and I'm only going to do a quarter of this, okay? So I'm only going to do this, so I need to multiply by 4. So 4 times the integral from 0 to pi over 2, because those are my times, 0 to pi over 2, the square root of dx over dt squared, so that'd be negative 4 sine of t squared plus dy over dt, which would be 4 cosine of t squared. I got to extend my square root, okay, and then dt. Okay, so this would equal 4 times the integral from 0 to pi over 2. And I'm going to say this, a lot of times we're going to do this with a calculator, okay? Like the next problem we're going to do with the calculator, okay? But I want to do this one by hand, okay? So square root of, okay, so this would be 16 sine squared t. And this would be plus 16 cosine squared t. This one's actually not going to be one that's bad by hand, okay? I know it looks awful right now, okay? So this is equal to the length, the arc length, right, is equal to 4 times the integral from 0 to pi over 2. The square root of, okay, so these two I can factor out as 16. And we have sine squared t plus cosine squared t. Do you see where I'm going to go with this? dt. What is sine squared t plus cosine squared t? That is 1. And so I have the square root of 16, which is 4. Okay? So heck, this is 4 times the integral from 0 to pi over 2. Square root of 16 times 1, right? And so that would just be 4 dt, right? And we can integrate this. Is this crazy? All right. So this is 4 times 4t evaluated from 0 to pi over 2, right? Okay. So that arc length, right? Arc length would equal, let me slide it up a little bit so you can see it. Glad I caught it. Okay. This would be 16 times pi over 2 minus 16 times 0. And so 16 times pi over 2 is 8 pi, the same as the circumference of a circle. Okay? All right? Wild, huh? Wild. Like, who the heck ever thought of this stuff? Okay? All right, so one more problem. Let's talk about that. Okay? And then we'll be done for today. Find the length of this curve, right? And I'm going to tell you right now, there is no way in heck you know what this is. Okay? I take that back. There is a way to do it. Okay, it's kind of hard though. Okay, yeah, I'm thinking of another way to do this. Sorry. I shouldn't be thinking in front of you guys. Okay, so t equals 0, right? T equals 0. Okay, that'd be cosine of 0, which is 1 cubed, which is 1, 2, right? So x is 2, right? And sine of 0, right? Sine of 0 would be 0 cubed is 0 times 2 is 0. Okay, so right here, this point right here is the initial point, right? Okay. Now I'm thinking this point's right here, and so there's symmetry here again, right? So we could multiply by find this one piece, right? And then multiply by 4, right? We could do that again, okay? Okay. So I'm thinking this is going to be at pi over 2, okay? Because and a lot of times I'm thinking this is, well, it says 0 to 2 pi, right? So a lot of times you're going to complete because the period for sine and cosine is 2 pi, right? You're going to complete the curve. You're going to complete a whole curve, all right, when you go from 0 to 2 pi, okay? And then because right at 2 pi, that's going to be the same as 0 for these trig functions, okay? Not always, okay, but a lot of times, okay? So 2 pi, okay, if we do 2 pi, right, that would be cosine of 2 pi, which is 1, right? Or, yeah, and well, we'd be back here, okay? I'm sorry. I'm trying to figure out this point right here, right? I'm thinking that's going to be at pi over 2. So what's cosine of pi over 2? Cosine of pi over 2 is 0. When I cube it, it's 0. Times 2 is 0. So x is 0, right? Okay, so it's either going to be this point or this point, right? At pi over 2. So at pi over 2, sine of pi over 2 would be 1. 1 cubed is 1 times 2 is 2. Okay, so this right here is t is equal to pi over 2. Okay, so if we integrate from 0 to pi over 2 and multiply it by 4, we will have the entire length of this curve. Okay. All right, so here we go. Okay, so we got to find dx over dt, right? Now, we got to rewrite x first, though. Okay, so x is equal to 2 times cosine of t cubed, right? That's what that cube means right there, okay? So that means dx over dt would have to be 2 times 3, which is 6, times cosine of t squared, right, times the derivative of cosine of t, right, which would be negative sine of t. Okay, so dx over dt is really equal to negative 6 cosine squared t sine of t. Okay, same thing here, but it's going to be sine, right? So y is equal to 2 times sine of t cubed, right? So then dy over dt would be 6 sine of t squared times derivative of sine t, which is cosine of t. Okay, so dy over dt is equal to 6 sine squared t cosine t. Okay. All right, so now we want to find the arc length, right? I'm going to come down here a little bit. So the arc length would be, okay, and we're going to go from 0 to pi over 2, and we're going to multiply it by 4. So 4 times the integral from 0 to pi over 2, the square root of, and it would be -6 cosine squared t sine of t in parentheses squared plus, and then dy dt squared, right? So 6 sine squared t cosine of t, close parentheses squared, extend this long square root, and then dt, okay? So then this would be 4 times the integral from 0 to pi over 2, the square root of, I would get rid of the parentheses in here because you just need to square the -6, the cosine squared, and the sine, right? So that'd be 36, okay? Cosine to the 4th, so cosine to the 4th of t, sine squared t, right? Okay, and then plus, this would be 36 sine to the 4th t cosine squared t, and then dt. Okay, now when we put this in their calculator, our calculator we can't put it in our calculator like this, right? So we're gonna have to use parentheses here. Okay, and that's what we're gonna do next. We're gonna put this into our calculator. Okay, so I'm gonna go to my graphing calculator and I'm gonna put that integral in. Okay, so we want to type 4 and then integral, and then number 4. We're going to go from 0 to pi over 2. And then square root. Okay, and we have 36. Then we need to put a parenthesis, and then it's cosine. So cosine x. Close the parenthesis for the cosine, and then we need to raise it to the 4th. Then come down out of the exponent, and then we need to do sine squared, right? So then another parenthesis, and then sine of x. Close the parenthesis for the x, close the parenthesis for the sine, and then we need to square it, right? Okay, and then plus, and then 36, and now we need to do sine to the 4th, right? So parenthesis, sine of x, close the parenthesis for the x, close the parenthesis for the sine, and then raise it to the 4th, come out of the exponent, and then open a parenthesis, and then cosine, and then x, close the parenthesis for the x, close the parenthesis for the cosine, and then square that, and then come out of the square root and get over to the dx, right? And dx. And you can't even see it on your screen anymore, right? And it comes out to be 12. Okay? Is that wild? Okay? So let me tell you another way. Well, let's just go back, okay? Rarely do these give you nice numbers. Rarely. I want to make that really clear. Rarely, okay? These are kind of geometric shapes, okay? All right? Okay, so let's go back. Technically, I shouldn't have put an approximation, right? Because it actually gave us an exact value, okay? So this is exactly 12. Okay? And that is it, okay? All right, that's it. Let me get the assignment sheet, and we will okay, so today what I want you to do is, and it's assignment 11-2, actually 12-2, okay? It's okay if you write 11-2. It's the page 541, and then 17 through 33 odd, okay? I'd like you to do those, okay? And then tomorrow we're going to start with vectors. So that's it for parametric functions, okay? And then we have 2 days on vectors, and then 2 days on polar functions, okay? And polar functions is just, polar functions are they're neat. You're gonna, if you pass the BC test, you're gonna see something very similar, okay, to polar functions these last 2 days. You're going to see a thing called spherical coordinates and also cylindrical coordinates, and you'll start seeing those in your third semester calculus, because if you pass the BC test, you're going to be in third semester calculus, which is pretty cool. All right. You would have gotten through like the thing that like really people struggle with, right? And it's the convergence, all the convergence tests. That's what's usually hard for a lot of people. Okay. All right. So I want you to do page 541, 17 through 33 odd. I think there's some graphs. I'll make sure I include that. Okay. And you guys, I hope you're having a wonderful day. Okay. I hope you have a great day and a blessed day, and just take care. All right. Take care of you. Take care of your family. All right. See you later. Bye-bye.